All right, part 2, lesson 9.4 on inverse trigonometry. So it says use a calculator to evaluate use a calculator to evaluate arc sine 0.3. So turn on your calculator. Oh, here. So if you go to your trig button, it won't say arc. You can just go to the inverse, the little negative one, for sine, and then put in 0.1 or 0.3, and then Control Enter. Now my calculator is in degrees, so that would be the answer in degrees. So I'm going to change my calculator. Go back on here. I have to change my setting. I've been using this calculator for my Math 3, and I put it in degrees. So the document settings here, I need to change it to radians. And let's do it again. Is it still that? No, it's still in degrees. How did I change this? So let's see if this one changes it now. Now it's in radians. Alright, so let's try it again. So 0.304 or 5. You can truncate. Use your calculator, arctangent, inverse tangent of 3, 1 point, or negative 5. Where did I get 3? So inverse tangent of negative 5/2. That's negative 1.190. There we go. Getting on track here. Get my head in the game. It says simplify without a calculator. So to simplify this, inside the parentheses, arc sine inverse means what angle is that true? So when the y coordinate is √3/2, what's the angle? And the answer is the angle is pi/3. And then what's the value of sine at pi/3? And the answer is √3/2. That's because these undo each other. You have a sine in the inverse undoes what sine does and gives you the answer. But be careful. So let's see if that always works. Inside, if it was the other way around, if arctangent was on the outside and tangent was on the inside, then you'd have to be careful because of the domain restriction. But here with the arctangent on the inside, they actually undo each other. So do I know the angle where this is true? That's not a point on my unit circle where y/x would equal 3. So I don't even know what it is. But I know they undo each other, so the answer is 3. Here, this is where we need to be careful. So be careful that this angle is in the restriction. So like if I look over and skip to D, I got to be careful there. For this one, they do undo each other. And the answer is pi/3. But for this one, notice this answer is not within my restriction for arc sine. It's 11 pi/6. So I need to recognize 11 pi/6 is here in quadrant number 4. What's the correct way to write that angle for inverse tangent? Or inverse, for inverse sine. And that answer is a negative angle that matches it, that's coterminal. So the correct answer is negative pi/6 because that's the correct restriction for inverse trigonometry. So in this case, pi/3 was within the correct restriction for inverse. So there you go. But 11 pi/6 wasn't. So I had to change it to a coterminal angle that does go within my restriction. And again, you can go back, if this diagram helps you, to recognize where are the angles found for inverse trigonometry. So 11 pi/6 was in this quadrant, but I had to write it as a negative angle. The same angle. All right, example number 6. Can you solve that equation? So step 1 to solve it is how do I undo arc sine? And the answer is sine. That's the inverse of that. So both sides sine. So they undo each other, and you have x squared subtract 3. The value of sine at pi over 2, that's the y coordinate up there, is positive 1. Add 3, so it's that. Take the square root. So the answer is positive or negative 2. 7. Sketch a right triangle and evaluate without a calculator. So here's something, 2 over root 5. That's not a point on the unit circle. So if I want to evaluate tangent using those numbers, I need to draw a right triangle. And in this case, because cosine is positive, the right triangle is actually going to be in quadrant number 1. There's the angle there. I don't know the angle, neither do I need to know the angle. The definition of cosine is adjacent over opposite, SOHCAHTOA. Tangent using this triangle. So I need to find the missing side. So leg 2 squared, the other leg I don't know, the hypotenuse. So when I solve this, I get b equaling 1. That's the missing side. Now use this triangle to solve for tangent. So the definition of tangent, SOHCAHTOA, OA, opposite over adjacent. So the answer there is 1/2. Let's see if we can do that again over here, but it's going to look algebraic rather than with numbers. So given that y equals arc sine x, find cosine y, we're actually going to do the same thing. We're going to draw a triangle and do this algebraically. We're actually going to find the rules for derivatives for inverse trig doing this. Here we go. Here's the angle that I don't need to know. The definition of sine is opposite over hypotenuse. So I don't see 2, so think of it as x over 1. So the opposite side is x, the hypotenuse is 1. What would this missing side be using the Pythagorean theorem? So again, leg squared plus, I'm just going to call that b squared is equal to 1 squared. I want to get b by itself. So 1 squared is 1, and then subtract x squared and take the square root. Because we're in quadrant 1, it's going to be positive. And then what's cosine y using that triangle? So the definition of cosine is adjacent over hypotenuse. So it would be root 1 minus x squared over 1, or just root 1 minus x squared. That's what cosine y would equal. So again, you found what y, and you took what y equals, you drew your triangle, and then from that triangle, find cosine based on that triangle. Now, use your work from example 8. Here we are. To find the derivative of arc sine x. So, you will need to do the work implicitly to be able to understand it. So, we need to go y equals arc sine x. And realize that sine y, well, what is it? Go back to this triangle. Opposite over hypotenuse, x over y equals what? X over 1, which is x. And that cosine y times y prime then would equal what? Well, the derivative of x, see how we took the inverse and then reversed it, or inversed it back to sine? So the value of that, where x and y had been switched around, what's the derivative of this? Is 1, and the derivative of cosine y. So let's put it together. Answer to that is 1. If I put it together, right here. So let's look at this again. If I took the derivative of arc sine x, and here comes the big point, it's going to be 1 over cosine y. which is 1 over the square root of 1 minus x squared. So, as confusing as we got to it, we have a new rule. That cannot be confusing. A new rule. So what's the derivative of inverse sine? And the answer is 1 over root 1 minus x squared. So, don't get a headache over the last one to know. The AP exam, we're not going back and proving these rules, we're using the rules. So for sine, there's the rule. Do you see that cosine has a similar rule, but again, it's negative? Put the same rule. Arctangent, a new rule. 1 over 1 plus x squared. So, different ways to remember it. If you think of that triangle where you have x over 1 and you solved for the missing side, you can see where 1 minus x squared came from, and it's 1 over that. Our cosine is similar but negative, and arctangent is completely different, not subtracting but adding, so the order doesn't matter, and no square root in the denominator. Now the truth is that when we integrate, we actually don't need both of these when we integrate. So the next lesson, because they're basically the same except one's negative, you can always change the hook for the negative one and just use 1 and not worry about cosine. So you'll see that in the next lesson. So how are we going to differentiate it? Let's get down to like doing the work. Following the rule. Are you a rule follower? Let's see. So arctangent, what's the rule? So the rule for arctangent here is 1 over 1 plus, now whatever's inside the parentheses, which is 2y minus 1 squared times, and there's a hook. What's the derivative of 2y minus 1? Just 2. So can you see that hook? Follow the rule, and then the hook. Let's try the next one. Rule follower. Arc sine root x. So what's the rule that we need to do here? So the rule for the derivative is 1 over the square root of 1 minus whatever's inside there, root x squared, and then the hook. And the derivative of root x is 1/2 x to the negative half. And yes, you could write it a little simpler if you wanted to. You could have a 1 on top. That x, we have the 2 in front of the x to the negative half, so you have a 2. X to the negative half is root x times, and the square root and the square undo each other, so it's just 1 minus x. Unnecessary. But you could see that you could write it that way. 12. The rule follower. Be a rule follower. Derivative. Negative 1 over the square root of 1 minus, inside the parentheses, ln t squared. That's the rule. And now the hook. What's the derivative of ln t? 1 over t. Done. And again, you could write this, multiply the tops and bottoms. You could have negative 1 on top. If you like the t, often you put that in front of the square root and put it all together. So, bottom line, this lesson has 3 new rules and then the hooks. You have to work and practice and be a rule follower. All right, good luck.